The terms pH, acids, and bases get thrown around very often, but not often are they well defined. A shampoo being called pH balanced, or needing to get more basic foods in your diet to keep your body at the right pH. Well, in chemistry, the two most common definitions for acids and bases were devised at around the same time by two chemists named Johannes Nicholas Bronsted and Thomas Martin Lowry. A Bronsted-Lowry acid is defined as any compound that donates a proton, and a Bronsted-Lowry base is defined as any compound that accepts a proton. In this context, a proton is defined as the H+ ion. pH is based on the concentration of the H+ series, and formally defined as the negative log of the hydronium ion concentration for aqueous solutions. Hydronium being H3O+, which occurs when H+ attaches itself to water. The typical concentration of hydronium in pH neutral water is 10 to the negative 7 moles per liter. Taking the negative log of this gives a value of 7, so the pH of a neutral solution is 7. If acid is being added, the concentration of H3O+ will increase, and if base is added, the concentration of H3O+ will decrease. This is because the base will pull the H+ ions out of the solution. If concentration of H+ or H3O+ increases, then pH will decrease, and the inverse will apply for bases. The pH scale goes from 1 to 14, where a very acidic solution will have a pH of 1 and a very basic solution will have a pH of 14. It is possible, albeit uncommon, to go below 1 or above 14. An example of a Bronsted-Lowry acid would be hydrochloric acid. When HCl is dissolved in water, it splits into H+ and Cl-. The H+ immediately reacts with the water to form H3O+. An example of a Bronsted-Lowry base would be ammonia. When dissolved in water, the ammonia accepts a proton from H2O, turning itself into NH4+, or ammonium, and leaving an OH- in the water. OH- is a strong base. One relevant effect of pH on today's world is ocean acidification. You most likely have heard of it, but may not understand the chemistry of it. Here, I will attempt to explain it. As you are no doubt aware, modern society is pumping out CO2 into the atmosphere at an increasing rate. CO2 is absorbed into and reacts with the water, where it forms carbonic acid. Under normal conditions, this would be of little concern, since the ocean is so big and typical levels of CO2 are not too high. But with industrialization, billions of tons of CO2 are added into the atmosphere, which increases the CO2 concentration enough to have an appreciable effect. Why does the pH of the ocean matter? So what if it's a little acidic? Well, virtually every organism, marine or otherwise, is sensitive to pH. Organisms that have hard shells are particularly impacted because their shells are made of calcium carbonate. Calcium carbonate will react in acidic conditions to form carbon dioxide. Even if the pH isn't low enough to completely dissolve their shells, it makes it so that there are less carbonate ions available in the ocean, making it harder to construct their shells and causing weakness. Another organism that needs carbonate ions are corals. Corals and coral reefs are particularly important because they provide a habitat and a niche for a diverse array of organisms. Destruction of reefs will be damaging to every species that has carved a niche for itself in the coral reef environment, and will represent a major blow to biodiversity. Pretty much every animal needs the pH of their environment to be just right. For example, fish and shellfish have a reduced ability to detect predators at a lower pH. Even a relatively small change could have drastic consequences due to the interconnectedness of the food web. A decrease in the fish population could also cause a decrease in the population of another animal. These consequences are not limited to just organisms in the ocean. It could also impact people. For example, since there are many countries where fishing is a major part of the economy, a reduction in the fish population could have financial consequences. We can also use chemistry to help fix the problem. Already measures are being put in place to help reduce the damage. We have mechanisms in factories and power plants to reduce the amount of CO2 that gets into the atmosphere. Research is also being done to see the effects of using plants that consume CO2, such as seaweed. There is much work being done at the moment, and there is a lot of work left to do. And these problems will be the things that plague both this generation and the next. We will need bright minds to come up with smart solutions to these problems. And who knows? Maybe it will be you that comes up with something revolutionary. So let's recap what we learned. We learned about pH and what acids and bases are. We also learned about ocean acidification, how it happens, and what its effect is. That's it for this week. Tune in next week where we will talk about thermodynamics and sources of energy.